Okay, so we're going to solve the entry task for today. So remember, depending on if you have Monday's class or Tuesdays, your date will be 10/5 or 10/6. And I have mine on page 7. So don't forget, if we use the whole page, you can pop that into your table of contents. So a family goes on a road trip and drives 20 kilometers south, then 99 kilometers east. So we want to find multiple things. We want to diagram it first. Then we want to find the distance, the displacement, and the average speed. So we'll go through all of those. So first off, the diagram is really important. So I've told you that before with the last displacement. It gives you a visual of the numbers that you're going to be putting down in your problems. So in this case, they're going to make a right turn. They're going to go from the south to the east, or headed south and then headed east. So in my diagram, I would just draw the car kind of going down. And so we know it went south, and that's going to be 20 kilometers. And then it's going to turn and go to the east. And that's going to be 99 kilometers. So we know that's going to be quite a bit longer. I'm not going to make it super long just because this isn't perfectly to scale, but you get the idea. This is 99 kilometers. They went all the way to the east after going south. So you can see here they made a right angle. And we also know that a right angle leads to a right triangle. So that's going to be really important for us as we get into the displacement. So this was the little car. I'm really terrible at drawing, you guys. You'll learn that if we go back to school especially. Here's a little car. Here's where they started. And this is where they ended. Okay, so they didn't come back. They didn't turn around. This is the start and the end, or the finish, either way. So the first question asks for distance. So we know distance is the total amount traveled. So we don't have to do anything crazy here. We just need to know what was this plus this, and that's the total amount. Didn't matter about turns. So in this case, we're just going to do 20 kilometers, and we're going to add that to the 99 kilometers. And we know that 99 plus 20 is going to be 119 kilometers. Okay, so that's really simple. The distance was the easy part. All right, displacement is a little bit more advanced in this case because they didn't just go somewhere and come back or on a number line that was straight where they came back straight. They made a right turn. So we need to know the distance between the start and end. We want to know the straight line, the way the crow flies, like I said in that one video. So because this made a right triangle, we know that the hypotenuse of the triangle in algebra, we can figure out that there is an actual equation for that. And we know that as the Pythagorean theorem. So if we called this side A and we called this side B, that this would be side C. So the hypotenuse of a right triangle, okay? So according to the Pythagorean theorem, the equation is a squared plus b squared equals c squared. So we are going to use that to find c, and c is the displacement. Okay, so if a is 20 kilometers, we're just going to plug it right in. So I'm going to do 20 kilometers, and I'm going to actually put parentheses around it and put the squared on the outside. The reason is because I want to make sure, and I mentioned this before, I square everything inside. I want to square the 20, and I also want to square the unit of kilometers. And you'll find out why later, because we need to end with kilometers by itself, but there's a reason we need to make sure it's squared in the beginning, okay? And we're going to add that to b, which is 99 kilometers. And again, put that parenthesis on the outside, or parentheses and the squared on the outside, so I square everything inside of it. And I'm going to still leave the c squared there. We didn't do anything. We don't know c yet, so we're going to solve for c. So I'm going to, I probably didn't give myself a ton of room. I'm going to pull up my calculator, and I'm going to show you a couple things. If you don't have a scientific calculator where the squared button is, so maybe you don't have your phone that has a calculator or whatnot. Remember, your Chromebook has one, but if you're just using a regular calculator, you have one from maybe the dollar store, and it looks kind of like this. No squareds, no square roots. If you're squaring something, technically squaring something means you're multiplying by itself. So if I didn't have the squared button, I could go 20 times 20, and that is going to give me 20 squared. So 400. Now I squared 20, but I also need to square kilometers. It's going to be 20 kilometers squared. Okay, remember, we'll get rid of that later, but we have to have it there now when we're talking units. Okay, the other one is 99. So I'm just going to show you, if you did have a scientific calculator, the squared button is this, oops, lighting, is this X2 on my iPhone, and it would look similar if you found it, if you had a scientific calculator. So I could do 99 plus 99, or I could go 99 and hit the squared button, and it's going to tell me that's 9,801. So plus, I'm just bringing it down, 9,801 kilometers squared, because I square everything inside the parentheses. So I have a simple addition problem at this point, but I'm going to still carry down my c squared. I didn't do anything with the c yet. So in this case, I need to finish out the problem here by adding 400 plus 9,801. So since I already have 9,801 plugged into my calculator, I'm just going to add 400 to that. And that's going to give me 10,201. And since I still have kilometers squared, they're like units, I can add them. I have to still have kilometers squared. These pencils break so much on me. And I still have c squared. I didn't do anything with c squared yet. So remember, we're looking for c by itself. We're not looking for c squared. So we're going to have to deal with that in a second. So I don't want kilometers squared, and I don't want c squared. So to get rid of a squared, you have to do the opposite to it. So the opposite of squaring something is square rooting it. So I have to do that to this side to get rid of the squared on the c, but I also have to do it to the other side, because remember, what you do to one side in a problem, you have to do the other equal side of the equal sign. And since that kilometer squared there, that's going to actually help us out. Okay, and due to my spacing issue, I didn't make very good space. I'm just going to put it over here. If I square root c squared, I get c equals, and I just flipped them around, so don't worry. What is the square root of 10,201? So since I already have it plugged in, hold on, someday, to my calculator, and I'm sorry, I have to flip it so it's, now I'm going to hit the square root button. Now there's nothing magical that you can do if you don't have a scientific calculator for square root, but most of the dollar store calculators have a square root button. So in this case, it's this X with the square root sign and a little 2 on the inside. So I'm going to hit that button and square roots it for me. The answer is 101 kilometers. So I didn't just square root the number 10,201. I also square rooted this kilometer squared, got rid of the squared. So basically got rid of this squared, got rid of the squared, and told me that c is 101 kilometers. So I can go back up to my diagram and label that. And if you think about it, it makes good sense. It's longer than the bottom, longer than the bottom and longer than the top, but it's not like you added them together. They didn't go this whole distance. This is the way the crow flies. If you were a bird, you'd fly straight. You wouldn't go around all the turns, okay? So that is our displacement. All right, the last thing is asking the average speed. So remember, speed equals distance divided by time. So I definitely have a distance. Okay. Oh, I forgot to tell you the time up here. I forgot to write it down. Oops. Forgot to write it down. They went that in. Let me just make sure I have the correct numbers in my calculator, because I already plugged it all in my calculator and solved it, and then realized I didn't write it down. So, oops. 1.5 hours. Sorry, hold on really quickly. I have a technical difficulty going on with my Okay, I went back and checked. It's 2.5 hours, not 1.5 hours. So hold on, let me go back. didn't write it down and then I couldn't remember what I put. Okay, so they did that in 2.5 hours. So that was the time. So now I have a speed and I use my distance and my time to get average speed. So remember, if they drove this long way, 119 kilometers, they're not going to go the same speed the whole time. That's why it's the average speed. Sometimes they're going to be going slower. They might be going through a town. Sometimes they're on the freeway. They might be going faster. Okay. So now we're going to look at it and fill in the variables. We need an S, a D, and a T. I didn't leave much space, so I'm squeezing it in there. Since we're looking for speed, that's going to be X meters per second. Now remember, this is distance that we're going to use for speed because it cannot be negative. So we're going to use 919 kilometers as our distance. And our time is 2.5 hours. So remember, typically on here, I would kind of, underline, what am I given? Okay, so I'm given all these different numbers. It's really important to know that. So I'm going to plug that into my equation. Speed equals distance divided by time. So X meters per second is my speed. I'm going to equal my distance, 119 kilometers. I'm going to divide that by my time, 2.5 hours. Now, our typical unit was meters per second before for speed. But remember, it's a distance divided by time. So in this case, we're doing a kilometer divided by an hour. So we're going to get a kilometers per hour in this case. So I'm going to put up my calculator. I'd already done it. Remember I said that. 119 divided by 2.5 equals 47.6. And that is kilometers per hour. So remember, they didn't go that speed the entire time. That's their average speed. So sometimes they were going maybe 25 kilometers per hour in town. Sometimes they were going 0. Maybe they came to a stop sign. Sometimes they were going maybe 100 kilometers per hour. Now remember, this isn't miles per hour, so 100 kilometers per hour is pretty normal when you're talking kilometers per hour because kilometers are smaller than miles. So if you were going all these different speeds the whole trip, that's the average. All right, next one. A basketball player is running lines and runs down the court 14 meters and then touches the line, then turns and runs back, but passes the starting line by 5 meters in, see, I didn't write all my times down, 16 seconds. Okay, so we need to solve. And just like the first one, I want a diagram and I want the distance, the displacement, and average speed. So in this case, we're going to diagram the line that the basketball player did. So they are going to start at 0 and they're going to run down to the starting line, to the end line and touch it. So if you've ever been in basketball and had to run lines, that's what you do. That is 14 meters. And they're going to turn around and run back. Oops, I'm going to put it on the bottom so I have some space. There we go. They're going to turn around and run back, but they're not going to go to the start line and stop. They're actually passing the start line by 5 meters. So over here, if this is 0, just get a little more space. If this is 0, they passed it by 5 meters. So remember, we talked about what happens when you go in past 0, it becomes a negative. And since it was by 5 meters, their ending point is going to be at negative 5 meters. Okay, so this is their beginning, their start at 0. Their end was at negative 5. So this 14 meters over here doesn't mean anything for the start or the end, but that is part of the total distance they went. So with that said, we need to do distance. So B is distance. So to get the distance, we want the total amount they ran. Remember, distance cannot be negative. So in this point, we don't care that it is a negative down here. We just wanted to know that they went 14 there. They came back to the start at least. So we know they went 14 there. They also went 14 meters to get to 0. And then they went another 5 meters, even though it was negative when we're talking number line, it's 5 meters when we're talking distance. So 14 meters there, and then 14 meters back to the starting line, and then an additional 5 meters past the starting line. Okay, so if you were to add 14 plus 14, you might know that that is 28. And then we're going to add an additional 5 to that, which makes 33 meters that person ran. Okay, so we want the displacement. Now we know displacement can be negative. We also know that a displacement is not the entire distance. It's the difference it went from start to finish. It's the displacement or the change in position from start to finish or end. So remember, we have our final position minus our initial position, which equals displacement. So our final position is actually negative 5 meters. Okay. And our initial position is 0 meters. So it's the difference between the two. So we're subtracting, okay, our 0, and I'll put the meters by it just so you don't get confused. But remember, zeros don't need units. Okay, and you might be able to do this in your head, which is really what you should be able to do. But just in case you get confused sometimes with the negatives and the 0, I mean, you can look at the number and you can figure out that they went from 0 to negative 5. So the displacement should be negative 5. But if you ever feel really stressed out about, are you sure? Because you get confused with the negatives, just do a quick calculator check. 5 negative minus 0 equals, because anything minus 0 is itself, still negative 5. But I know how sometimes people do get a little stressed out with negatives and positives and all the different adding and subtracting. So kind of get yourself used to it. But if you got confused looking at this, just look at this. This is pretty obvious. 0 to negative 5 is negative 5. So their displacement is a negative number. And in this case, I asked for their average speed. But I'm also going to do a quick little average velocity just for the fact that I want you guys to know it. So the average speed is still speed equals distance divided by time. So in this case, the speed is x meters per second. So our S is x meters per second. Our D is going to be the distance they went. So remember, we want the whole distance. And their time is 16 seconds. So in this case, I'm going to go 33 divided by 16, and that's going to give me 2.06. I'm going to round it up to 2.1. Oh, actually, I forgot to plug it into the equation. I better do that real quick. X meters per second equals 33 meters divided by 16 seconds. Remember, it's in meters per second. And that's going to be 2.1, and that's meters per second. Okay, so we got the speed. And I'm going to throw in the velocity because we have this negative displacement now. So now we're going to get to see about the velocity being negative in this case. Sort of like the number line, the motion terminology test you guys were doing, which I know some people said was hard when they asked about velocity with the negatives. So we're going to call that E, average velocity. So remember, velocity equals displacement divided by time. In this case, we have a V, a D, and a T. Our velocity is x meters per second. Our displacement is negative 5 meters. And our time stays the same, 16 seconds. So you're going to plug that into our equation. X meters per second is the V. Displacement is negative 5 meters. And we're dividing that by 16 seconds. So in this case, you know, if you plug it in, you do want to make sure you hit that negative, divide it by 16. Okay, you're going to have a negative velocity, negative 3.1. Oops, goodness. Meters per second. So there's that negative velocity there. Okay, so that is how you solve the entry task.